atoms.
If these Lego bricks had existed in the early part of the 19th century, chemists could have used them to help illustrate something they were seeing in their experiments. A phenomenon that led to our next great discovery. The atoms of particular elements, such as sodium and chlorine, seem to combine with each other according to fixed ratios. It was this combining power of atoms that inspired German chemist August Kekule to develop a system for visualizing the chemical structure of various molecules. Kekule represented the atoms by their symbols, then added marks to indicate how they bonded with each other, like links in a chain. It was a simple yet elegant formula. Chemists now had a device for clearly illustrating the chemical structures of the molecules they were studying. There was just one problem. Benzene was the only known chemical that would not fit Kekule's formula. Benzene's chain of carbon and hydrogen atoms required more combining power than the formula would allow.
And all these organic chemistry professors are puzzling about it and offering different explanations. And one of them, August Kekule, sitting by the fire one evening, falls asleep and starts to dream about a snake. And if you think about a snake, what Kekule dreams of is the snake catches its own tail. And if you think about this, maybe the thing is a ring. And that gives you an answer to the puzzle.
The 6 carbon atoms of the benzene molecule weren't linked in a chain. Like the snake, they formed a ring, each with a hydrogen atom attached, with alternating single and double bonds. Within a short time, Kekule's insight was confirmed, and its effect was revolutionary. Chemists knew that all organic substances contained 1 or more carbon atoms in their molecules. With Kekule's discovery, they now had the underlying formula to explain how carbon combined with other molecules to form a world of chemical compounds. The modern era of organic chemistry was born.
Now, with this thing being so simple, that is to say, the snake bites its tail, why is this considered a great discovery?
Here is a recipe for new drugs, new medicines, new understanding. If you go back in time, in Dalton's day, a couple of hundred compounds. Soon it's a couple of thousand. Soon it's 10,000. Astonishing. Soon it's 100,000. Last year, 15 million new compounds were registered, all built on this simple template. This is a work of genius.